Okay.
Okay, Radhika, should I start then? Good evening to one and all present here. I am Shohardo Viswas, a coordinator at VIT Hack 2020, and I shall have the honor of being your host for this webinar. Today, our esteemed speaker, Mr. Dinesh Shanmugan, will be speaking on challenges building software at scale. Mr. Shanmugam, an alumnus of SRM University, has worked with some of the leading mobile phone manufacturers and e-commerce market disruptors and has worked with big names such as Redbus. Currently engineering manager at Gojek Tech, he's a specialist mobile software engineer with expertise in Android, Kotlin, Java, and AOSP. He preaches good engineering by building software that is scalable, maintainable, and easy to use. Sir, it is with immense respect and warmth that I transfer the mic to you to inspire us with your words of knowledge and experience.
Thank you, team VIT. So it's a pleasure to be over here virtually with you guys. So over the next 30 to 40 minutes, I'll speak about my experiences building software for millions and millions of users worldwide. Right. So let me start by asking you folks a question. How does it feel like when an application that you build is being used by, say, 20 million users, and the application that you build is generating a revenue of close to 1% of the GDP of an entire nation, right? So these are things that are nervous, that are exciting, right? And having been through some of these experiences, I would like to share my experiences with you budding engineers, so that you can take a few salt from what I've experienced it. All right, so let's see some history so that you can appreciate the notion of scale, right? So if you were to begin a startup in 2002, 2002, 2005, right? So what you would do is you would set up your servers probably in your basement or probably in a computer lab in your college, and you had only 2G connections, and websites were prevalent. I mean, as far as I remember, I see only Wikipedia during 2002 and 2005, right? And mobile penetration was very low. If you guys remember, there's a phone called Nokia 1100, right? Which is just it's a brick, right? You can hurt somebody's head when you throw it at them. So that was the mobile phone that was very prevalent during 2000 and 2005. And what happened during 2005, 2009? So during this period, still the mobile penetration was low, right? So mobile phones were mostly Nokia, so they were running Symbian operating system, and Nokia came with a sort of a smartphone which was running something called Mimo operating system, and Microsoft had their own operating system called Microsoft Mobile, and still servers were in-house. By in-house, what you mean is what you see in your laboratory, right? In college laboratory, there are huge servers lying around. Those were the kind of infrastructure that you would see in any company per se, right? And yes, payments was still, you had only net banking, but it can be done only through websites. And after 2009, right, so there's something interesting happened. The first version of Android came in, right? But still, smartphones were mostly Nokia and Samsung, which were running Symbian, and Samsung was running an operating system called Bada. It's called Bada operating system. And websites and internet payments were starting to become a bit easy, and the load to existing servers, right, they were starting to increase. Right? So what do you do? So when you have a few servers in your home or in your college, right, and you see that there are a lot of users coming into your system, and the load to an existing server start increasing, what is the thing that you can do? The very logical thing to do is to add more servers, right? Buy more servers, plug them into your computer, plug them into your laboratory, and make them additional servers, right? But once you do that, you need to periodically maintain those servers, right? You need power backup. You don't want your servers going down, because you know what the pain if you're not able to order food through Swiggy when you're hungry, right? And you need a team of engineers who monitor the servers, who check the dust inside those servers, who you need power backup and all those things, right? So during this time between 2009 and 11, movie ticket booking and bus ticket booking, they were starting to pick up steam because they are mostly unorganized and they are getting organized. So I remember booking movie tickets in Satyam Cinemas, Chennai, and I remember booking tickets at Red Bus. Right? And after 2011, right, everything went for a toss. When the first Android phones started coming in, developers started building Android applications, iOS applications, and mobile web applications. So net banking, credit card, debit card payments started becoming a bit more easy. Everyone had an ATM card in their hand. This opened up a lot of market as well as a lot of challenges technically to engineers like us. What are these challenges? Right, so one is infrastructure, right? So you can't keep on adding servers again and again and again uh, in your laboratory. Obviously, you are going to run out of space in your laboratory for the in the first place, right? So there came up technologies called the cloud. What you use right now, Amazon Web Services, Google Cloud Platform, Microsoft Azure. Right? So what these guys do is you can start your startup with just a laptop. Like, they give you servers, right? So they tell you how many servers do you want, we'll give you. You don't need to worry about power backup. You don't need to worry about maintenance of those servers. Just leave it to us. So startups started moving to the cloud, right? As I remember, it was moved to the cloud. We were one of the first guys who went into the cloud, right? And obviously, you can choose what configuration you need. Do you want a Linux server? Do you want a Windows server? Do you want 2 GB RAM? Do you want 4 GB RAM? It is all up to you just specify, and on a click of a button, you will get those servers. So infrastructure was a challenge. So and then what happened? The number of users started to increase, right? So from 1,000 users per day, it became 1 lakh users per day, and then it became 6 lakh users per day. And what happens during that, right? So usually, if you are using Uber and Ola, so the peak traffic comes during the morning and the evening. So what do you do about that? The logical thing: let's provision 100 extra servers on the cloud to deal with this in the for the whole day. But what about the afternoons? The 100 servers that you provisioned will lie idle in the afternoon, right? So because it is money, you are spending money to provision those 100 servers, and it is lying waste during the afternoon. What can we do about this? That's when something called auto scale comes in. So, and this is called pay as you go model, and this became very prevalent after 2011. So what happens is you can tell Amazon Web Services that, you know what, I give you the freedom, and according to the load that I'm getting, you provision extra servers as and when you feel it is necessary. And if there is no traffic, decrease the servers and just make it one. So this flexibility allowed startups to make sense of the money they had. They would be spending less amount of money, as well as they will be reaping benefits as well. So this is called auto scale, and you guys can check out what auto scale is. This is a buzzword, and you guys definitely need to check this out. And the next challenge is latency. So what I mean by latency is, imagine that you are at Vellore and you have set up all your servers at Vellore, right? So if I'm accessing your website from Bangalore, it loads very faster. But if I access your website from USA, it loads very slow because the distance between USA and Vellore is large, right? This is called latency, right? So what do we do? I mean, you cannot go ahead and set up an office at USA, right? That is next to impossible. But in the cloud, it is possible. Right? Clouds have a lot of regions, right? So you can set up a server in Singapore, you can set up a server in Latin America, you can set up a server in North America, you can set up a server in Europe, so that every user has every user experiences similar kind of experiences, and nobody would be left behind. And the biggest challenge is the phone form factors, right? So you have QWERTY keyboard, you have no keyboard, you have touch screens, and you have 5-inch phones, 2-inch phones, 3-inch phones, and stuff like this. Right? It's a foldable phone. It's coming up new, and we app developers, we are finding it tough to negotiate this foldable phone. We don't know what to do. And you have weirdos like this as well. So you see circular phones over here, right? So these are pretty crazy things that we engineers face very often, right? So users in India, they have 5-inch phones. Users in America, they have 6-inch phones. They have tablets. Whereas users in Indonesia, they still have 4-inch phones and 3-inch phones as well, right? So building for this is a big challenge, right? And how do we negate this? This requires pretty good planning, right? So you predict what most of your users are using, and you optimize the user experience to those phones. Obviously, you cannot design for circular phones, so this is out of the question. And then the next challenge is, you have too many phone manufacturers. You have OnePlus, LG, Redmi, Vivo, Samsung, blah blah blah. You have whatever you want, right? And you would have experienced this, right? So Swiggy or Zomato, whatever app you may use, works good in one phone, but it does not work good in the other phone. And because all the Android manufacturers, right? So they use a fork of the Android open source platform, right? And each OEM Each OEM means original equipment manufacturer. Samsung is an OEM, LG is an OEM, Redmi is an OEM. So they add their own customizations into it. That's the reason why you see different phones being different, although everything is Android phones. Right? So they customize a home screen, they customize device drivers, you know, 4 cameras, 5 cameras, and all those stuff. And custom apps also, they add all these bloatware and all those stuff. Okay, so this is a challenge, right? So users complain, right? It's not working in my phone, but the developer says it's working in my phone. So you guys would have encountered that a lot, right? And the most significant problem is internet, right? So you got 3G, 4G, 5G, and whatever G is going to come, you have 2G as well, right? So what happens to your internet bandwidth while you're traveling on a train or you're somewhere in the basement goes very bleak, but still users expect a very responsive application, right? And you guys do this a lot, right? So how many times do you pull to refresh your screen, right? Or how many times do you keep hitting the refresh button when you're booking tickets, right? So these are some challenges. Impatience. People are very impatient. So what do we do in those in those cases, right? So now the industry is moving towards a standard called offline first applications, where you don't care about the internet, but you have some experience, some good experience. The other thing is pretty intelligent, right? So you need to communicate well to the user. Right? So how would you feel if some app says, "Oops, something went wrong," right? It's pretty irritating. And if the app gives you some meaningful error messages, like say the internet is slow, this is something meaningful which you can relate to the application, right? So the application is talking to you in a language that you know, instead of something saying, "Oops, something went wrong," or 404 server error and all those things, right? And yeah, so generally in a startup, right, you have lots and lots of third party services that you depend upon, right? So if you want to use a weather application, right, what would you do? You will not set up your own satellites, right? You will tie up with some weather provider, and you integrate your application with those weather APIs, right? So a startup generally has interfaces with lots and lots of these kind of systems. So payments is a system, and SMS is a system, email is a system, location services is a system, weather is a system. So these are lots and lots of individual companies with which companies like Redbus, Gojek, Zomato, they tie up and they take their services, right? So there are fluctuation in these guys as well. So you know what happened when the S Bank phenomenon happened. PhonePe was out of business for 2 to 3 days. Why? PhonePe was using S Bank as a gateway, and once S Bank went down, PhonePe went down as well. Right. So this is one other challenge, because the third party systems that you interface with have their own way of working. Right. So you need to trust them, and you need to deal with them as well. But what do you do in these kind of situations, right? We always build backups, right? If one payment goes on, if HDFC Bank goes down, we'll right away redirect everything to State Bank of India, or we'll right away redirect everything to another bank that we have. So we have a lot of backups. And the other one is using techniques like machine learning. We forecast failures, just like how we forecast weather systems. We forecast failures using various signals that we can we we get. And there will be a separate team for monitoring all these connectivities in a very periodic fashion. So even at midnight, 1 a.m., if the servers go down, we'll get alerts, and there will be systems which can actually restart the servers instantaneously. So yep, so we cannot run out of business. We have to be live always. So we need to be on our toes always, right? Because there is millions of dollars at stake. So I can give you an example. In one of the projects which I was working, the size of the application increased by just 1 MB, and the amount of loss that we had to incur is 6 crores, right? 6 crores lost in just a span of 3 days, because the size of the application increased by 1 MB. Lot of users uninstalled the application. So all the money that we spent on marketing went for a toss. And so we have to be always on our toes. Yeah, and then comes the security, right? A lot of script kiddies out there, right? So what they do is there's a phenomenon called modded apps. where they clone your application, right? So if you search over the internet, you can find a lot of clones for Gojek app as well. Right? So what they do is they clone the Gojek application and make somebody and sell it to different people at a price, right? Where they take advantage of the system. And yep, reverse engineering. So you know how Geo Meet looks like when compared to Zoom. So an example. And yep, phishing. Right, you would have got those emails from a lot of you know, kings and queens in Africa, right? So this kind of phishing happens a lot, and the company is liable to all those stuff. And social engineering, you know what happened recently with Elon Musk and Jeff Bezos, right? So this is called social engineering, where folks compromise the employees of an organization and they get access to the internal systems, right? Because what you're doing all over here is you're chasing a moving target. It's like a cheetah chasing down a hare which is running at a very fast speed. So you always have to be one step ahead of them. So yep, security is a huge challenge, and there is a lot of scope for. There's a lot of openings in security as well, where security engineers are in high demand right now. And development itself is a challenge, right? So when you go into large scale applications, right? So it is okay if one or two guys develop an application, right? But what if hundreds of engineers work on a single application, right? Hundreds of engineers working on a single file. So that itself is a challenge. So you need to set up systems for developers as well, right? Say, for example, you know, the Android Studio that you guys may have used does not work for large applications, so it hangs. So if something hangs, how can you even develop? So we need to have a different team for just taking care of developers. So this would be pretty interesting to you guys. So there is a whole field called DevOps that is coming up. So one statistics is this year, I mean, in 2019, DevOps engineers are the highest paid in the entire software engineering industry, right? And you have different developer characteristics, right? So when there are hundreds of developers, so somebody may say that I want to have a curly brace at the starting of the line. Some may say that okay, no, I will have a curly brace at the in the next line, new line, right? Coding conventions, coding guidelines, architectures, lots and lots of developers have lots and lots of different kind of opinions. So it's a bit tough to bring everybody on the same plate. So this itself is a challenge right now. And yeah, bugs and crashes. So how would you feel if Zomato or Swiggy crashes when you're trying to order food, right? You'll be hungry, and what will the developer do? He'll be pretty pissed off as well. Right, so these are a lot of challenges when you're developing at scale. And there are some. These are the technologies that are making rounds at this point of time. So as young engineers, you may not be very familiar with all of these things, but what you can do is you can go ahead and look into these buzzwords and see what you can learn about them. And the intention is to make you aware of these technologies that exist right now, and you can go ahead and explore what you like. And so there are something called Dockers and Kubernetes, and AWS is Amazon Web Services, Google Cloud Platform, Microsoft Azure, which you guys would have heard about, and DevOps, which something called CA and CD, which is continuous integration and continuous deployment. So this probably once you go ahead into your career, you will learn more about these things. And if you are very interested in mobile application development, so right now the contention is between native applications and cross-platform applications. So native applications is something like for an Android phone, you need to build an Android app. For an iPhone, you need to build an iPhone application. But cross-platform is different. You write one piece of code, and that piece of code works in as an Android app as well as an iPhone app. So, and if you're interested in scripting, Ruby, Python, Clojure are good technologies right now. And where do you host your code? So GitLab and GitHub or avenues for this. And there's something interesting called Firebase, which is like a suite of tools. You guys can explore Firebase, absolutely. Right. So, and something called serverless computing. So this is pretty interesting. Serverless computing is pretty interesting, right? So if you want to execute a piece of code, right, remotely, only once a day, would you go about setting up a whole server for that, which will be running 24/7? Obviously not. So that's where serverless computing helps in. Serverless computing is something where you can execute a piece of code at any time you like, right, without any server. So that is serverless computing. So this is pretty good. You can explore that. But you know, there are always there are always challenges. But everybody was an amateur to begin with. So when I began my career in 2011, of December of 2011, I was an amateur, right? So I was running around, right? So the only thing that can help you is keep experimenting, keep learning, keep adapting, keep iterating, right? So don't be afraid of don't try to get perfection in whatever you're looking for, right? Just go with the flow. Don't be afraid. Failures happen, and it's all about learning from failures. So we have made a lot of mistakes. So mistakes happen. Mistakes are good. So as long as you learn from them. So yep, that's it from my side. So I'm Dinesh, and the folk that helped me design these slides is called V. So you can check out his LinkedIn as well. Thank you, guys. So if you have any questions in your mind, you can shoot it out right away.
Thank you, sir, for those wonderful words of wonderful informative words. We'll now be moving on to the questioning round. Our live chat is available to all our viewers as a medium to ask the questions.
So probably one of you can read out these questions, and I can probably answer.
Yes, sir. So yeah, Pranav was asking, how do you suggest to start a career in cloud computing and prerequisite for that?
First thing is anything that you need is a programming language, right? So for anything you need a programming language. So get yourself accustomed to any programming language of your choice. It could be Java, it could be Python, it could be Ruby, whatever it is, and go with one of the cloud providers. They provide free credits. Google Cloud Platform provides free credits. Amazon Web Services also provides free credits for students as well. So get your hands on that. So try to develop a simple web application or a website. Try to host it in one of the cloud computing platforms. That should help you.
Okay. Komila Sharma asks, what role does DevOps play in product management, product development?
Yeah. So I'll give you an example. Right. At Gojek, we have 100 engineers working on a single application. Right. 100 engineers working on a single application. Right. Which means that every line of code that you write has to go through rigorous checks, and these checks take about 40 minutes. Right. So every line of code that you write will go through, say, 40,000 test cases. Right. It will be run in at least 5 devices to make sure that it doesn't break. Right. So, but where do these test cases run? So this runs in a server, right? So, and only after all these test cases pass, you will be allowed to merge your code into the code base, into the master branch, right? So all these process which happens when you submit your code until it is merged into the code is maintained by a team of engineers called DevOps engineers. That is one of their jobs. The other one is when you upload an application to Play Store or App Store, right? You don't want a manual intervention. Obviously, if you are an individual developer, you can upload it on your own, right? But for large organization, this happens automatically. So every week, 4 p.m. on Friday, one application will be uploaded to Play Store, right? So who orchestrates all these things? So these are DevOps engineers. So they are a bunch of engineers who cater to developers.
How do you get into DevOps as a college student?
Um, first thing, you need to get away from at least see DevOps works for teams, right? So if you're individual developer, DevOps would not work out. So you need to find out a team of students who work together, right? And get away from your individual machines and start hosting your code in either in GitLab or GitHub, right? And in in GitHub, there is something called actions in GitHub. And so actions are something that is triggered whenever you commit some code, right? You can check if your code is compiling, right? So this you can start with GitHub Actions. So GitHub Actions is a good way to get into DevOps. That is the first preliminary baby step that you can take. But work with a team of engineers. Don't work alone. So if you're working alone, DevOps is non-existent. Work with 2 3 guys. Collaborate on a project. Try to work in a single file. It'll be challenging, right? Say you and your friend working in a single file, right? And when you merge your code, there will be merge conflicts, right? You both of you guys would be modifying this single piece of code, single line of code. Say you're working on line number 6, both are working on line number 6, so you will get merge conflicts. So that is the start of DevOps. Yeah, but go ahead, go into GitHub.
What exactly is the job of a DevOps engineer?
Yeah, so DevOps engineer builds infrastructure for all these things, right? So if you're working for, if you are just 2 3 engineers, right, it is pretty good, right? You won't get a lot of merge conflicts, right? If you are 100 engineers, what would you do? Right? They build tools for developers. They build tools, they build command line utilities, right? Say they make sure that code is always accessible. What if GitHub itself goes down, right? So the DevOps engineers, they own GitHub, right? They'll make sure that developers are able to develop smoothly. That is the primary objective of a DevOps engineer. They make sure that developers are able to develop smoothly, because if developers are not able to develop, you don't even have a product.
Okay, so Archana Sharma is asking, is there more value in industry for skills like DevOps and cloud computing, or the conventional data structures and algorithms outweigh?
So, data structures and algorithms allow you to get a job, right? So, they allow you to crack interviews, right? So, one thing that would help you in growing as a software engineer is to know as many technologies as possible. A software engineer, what he does, he designs software, he develops software, that's all. Data science algorithm is, right now, data science algorithms allows you to crack interviews. I mean, that's my perspective. But it is pretty important. So the more you practice data science algorithms, you become a bit good coder, right? But it's pretty important. But as long as you are in college, try to get your hands on into as many things as possible, right? So there are 2 kinds of software engineers, and one of them is called a generalist software engineer, right? A generalist software engineer is a jack of all trades, right? You just tell him what you want to do, and he'll figure out if something needs to be done in Python, or it can be done in Java, or it can be done in Golang, or whatever it is. His software engineering fundamentals are good, so any programming language is not going to be a matter for a generalist software engineer. So aim to become a generalist software engineer rather than a cloud computing engineer. If you want to go deep into research, then there's a different stream for you. But if you want to be a good software engineer, then focus on the fundamentals of software engineering.
Okay. So Pranav Sharma is asking, any suggestion for a fresher looking to get into software industry, keeping in mind the current scenario?
So by current scenario, you mean
the pandemic?
Pandemic. This is a challenge. This definitely is a challenge. When I graduated, there was a great recession, right? But the only thing that you can do is trust your skills, right? So you don't need to modify your approach because there's a pandemic or because there is a recession. Just keep doing what you are doing. Just trust your skills, because still there are a lot of openings, right? Still there are a lot of openings coming up for even freshers, right? But folks are not getting accepted in interviews. So the hit rate at what I mean, when I interview at least 40 engineers, we select 4 or 5 because there still are openings, right? So try to keep doing what you're doing, right? So try to keep practicing programming, keep practicing algorithms, keep practicing coding. That's all you can do. And other things would fall into place. Definitely start contributing open source as students itself, right? So that would become a big plus for you guys. however small that may be,
Uh,
even though it might be a small documentation on open source, that still counts.
so Krishna is asking, what do you think about the future of web dev?
Web is big time right now, right? So there is a contention between mobile and web right now, because in web you can iterate very fast, right? So if you want to change the color of a button, you can do it in say 1 hour. But if you want to change the color of a button in a mobile application, you change the color of the button, you upload it to Play Store. Play Store reviews it, it gets approved, and then the user still needs to update the application, right? So web development is big time right now. So anything you see Adobe Photoshop is going into the web, right? Anything that you see has a web version of it. So web development is definitely there to stay no matter what, and it's going big time right now.
So Nanika is asking, are there opportunities for freshers to directly become a DevOps engineer, or should they begin with another profile?
It is definitely possible, because at the core of a DevOps engineer is programming, right? It is all about, can you code? That's all. Can you code in Python, Ruby, Clojure, any scripting language, and can you code in Java? Because at the core of a DevOps engineer is definitely programming. So as long as you are a good programmer, you can become a DevOps engineer as well. Because other stuff like AWS, GCP, they are things that can be learned, right? But to begin with, for a fresher to get into DevOps, you have to be a good programmer. That's it.
So Shubham is asking, don't you think dipping your hand into many technologies in hopes of getting better can be exhausting and possibly deter one from finding what they would like to pursue sooner?
There is a see. How do you even know what you have to what do you like if you don't try a lot of things, right? So if you take Python, right, and if you take Python and you go deep into Python, how do you even know that you like Ruby or not? Right? So as students, right, try to learn as much things as possible, right? And eventually you will you'll know something that you are liking. But if you already have something in your mind, go ahead. So I know your senior Sparsh, right? So he was very clear. He liked mobile applications, so he went into Android deep. Either go like that, or if you don't know what you like, try different things. That's it. So because to begin with, I did not know what I liked, right? So I was doing Java, I was doing Python, I was doing mobile applications. Finally, I found that mobile applications is something that I liked.
So Lakshya is asking, what is the skill level expected from a DevOps engineer?
As I said, right, it's just to be a good programmer. That's it. So okay, if you can write good programs, if you can be very flexible in writing good programs, it's good. I had an intern who was working with me, uh, who was a good engineer first off. So if I asked him to write a program in Python, he would take 2 days. Even though he did not know Python, he learned it very fast and did it in 2 3 days. And he was able to write scripts in Ruby in 4 5 days, and he was able to pick up full stack in 5 6 days. So it's all being versatile. That's it. So at the heart of it is you need to be a good engineer. That's all. Can you hustle around? Um, can you get things working? That's all is expected.
So Yuvraj is asking, as a developer, do you think that machine learning is yet to reach its peak hype, or has it started to fade away? What, according to you, are the future aspects of machine learning?
It still is developing. So when I was doing my master degree, my one of my courses was text mining. So whatever I had learned like 7 8 years back is making sense right now, and it is big time. So the difference between 5 years back and right now is, 5 years back there were no tools. Right now, every technique that you know on machine learning, say latent semantic indexing or naive bayesian classification, there are libraries which can actually help you achieve this, right? So right now machine learning is all about, can you figure out the right technique for solving a problem, and if you are able to do that, then there are tools which can actually help you implement these. And so there are libraries like scikit-learn and TensorFlow, which already have the code for, say, naive Bayesian classification or a deep learning neural network written. All you need to do is figure out the techniques. But it's still growing. It is still growing, and we have lots and lots and lots of use cases. So all the startups that began in the 2000s and 2000 after 2010 have huge loads of data that is being accumulated, and this is the right time where all those data are being put into use. So machine learning is definitely has a lot of scope. It is coming up big time. So every startup is going data driven. All decisions are made based on data. So even at Gojek, we have a huge data team. So around 30-40 engineers just working on machine learning and data transformations.
Okay. So Sparsh is asking, do you think web-based frameworks like Flutter is going to replace native development? And
No,
also,
not
does
really.
Flutter work at scale?
I so it is definitely not going to replace native apps whatsoever, right? So native has its own advantages over Flutter, and Flutter is still nascent, so it is coming up big time, and it is very promising. But I don't think it is going to replace native apps anytime sooner, right? Because for Flutter to replace native apps, there has to be considerable investment that needs to be made, because for applications like, say, Amazon or Flipkart to go into Flutter, they need to rewrite the entire application to Flutter, which is not an option, right? So but yeah, so Flutter is still a good skill to learn, right? So there are lots of startups in Europe which I know who are right away jumping into Flutter. So they are not even building native applications; they are right away going into Flutter. So it still is a good. It still is better than React Native. So it is still a good skill to have. I mean, I'm learning Flutter actively because it is pretty promising, unlike React Native.
Okay. Ahmed is asking, in post-pandemic world, how would you recommend one try to find a job they like?
Sorry, I didn't get that. Can you repeat the question?
In a post-pandemic world, how would you recommend one how can one find a job that they like?
Don't worry about this. This is going to go away. So don't worry about too much about the pandemic. It is definitely going to go away. So already IPL is happening, so that's a good sign. So air travel is going to pick up. So everything is definitely going to go back to normal. So don't worry about this a lot. Right? So yeah, I mean, I know for sure that, see, if you have the right set of skills, you are going to find a job any day that you want, any day that you choose that you want. Right? So yeah, don't stress too much about this.
Dave is asking, sir, by a good programmer, do you mean knowledge of multiple languages or in-depth knowledge of just a couple of languages?
You can do it either ways. So either you can go vertically, say, if you choose Java, you can be a master of Java, or you can be a jack of all trades. So I do good amount of Java, but I can also do Python. I can also do Ruby. I can also do Clojure. So uh, yeah. But the skill that is, if you are going into a startup, right? So an early stage startup, you would be expected to be versatile. Right? So you don't need to be a master of one, but you will be expected to be versatile. And yeah, as I told you, that skill is called a generalist software engineer. So yes, always a generalist software engineer wins hands down, unless you're going for a very say a bank which requires you to know Java in and out, right? Or say a core team in Google which requires you to know Golang in and out, right? It's about how you foresee where you want to be. If you want to work in a startup, if you want to build a lot of applications, then being a generalist software engineer is good. Or if you see that I want to go into say ISRO, then you stick with your thermodynamics.
Okay, thank you, sir. I think that was a okay. There's one more question. Archana Sharma is asking, sir, could you tell some places in software where we will benefit from knowing in-depth Java?
Knowing in-depth Java. Okay, so see, Android still is a lot of Java. right? Say Uber uses only Java, right? Lot of banks they run on Java, right? Lot of mobile phones run on Java. If you develop for Android open source platform, the whole of Android open source platform is Java, right? So whatever your phone runs on, it does not run on Kotlin, it runs on Java, right? Say yes. So these are some of avenues. So large banks run on completely on Java, stock markets run on Java, and a lot of mobile applications. Uber runs completely on Java. Not a single line of code on Uber is Kotlin. So it's still there, but that's a very promising language called Golang, right? So it's Go-Lang. It's a very promising language. So lot of startups they have abandoned Java and .NET for Golang, which is pretty good. It's a pretty good language. I have had my hands into that. So yeah, you can try out Golang as well. But object-oriented concepts is the base of all these things. So know your object-oriented concepts well.
Okay, thank you, sir. I think that was the last question. Thank you so much for this wonderful opportunity to interact with you. I'm sure all of us had something to take away from this webinar. This brings us to the end of VIT Hack Community's first webinar. Subscribe to our channel and join the Discord community for more such sessions. And log into our website www.vithack.in to know more details about the hack. The PPT of today's session will be available in the link as a link in the description of this video. And thank you for being here. We hope to see you again. Stay safe.
Thank you. Have a nice day, folks. Bye bye. Bye.
Thank you, sir. Bye.
Yep. Signing off.